Welcome back to the channel. The wheelover point is one of the most crucial elements in ship navigation, especially when making a planned turn. It's the precise location where the helm must be moved to begin the turn so the ship follows the intended track and settles onto the new course exactly at the required point. Miscalculating this point can lead to the ship overshooting a channel, running aground, or entering danger. The calculation fundamentally depends on the ship's turning circle characteristics and its current speed. The turning circle is defined by the transfer, the distance the ship travels perpendicular to its original course from the moment the rudder is applied until it has changed heading by 90 degrees, and the advance, the distance the ship travels along the original track until it has changed heading by 90 degrees. For a successful planned turn, we are primarily concerned with the transfer and the drift angle. For a standard 90-degree turn, the wheelover distance is the distance measured along the new course line from the desired position of the turn, the apex, back to the point where the helm order must be executed. This distance is approximately equal to the ship's transfer, but it must be adjusted for the specific change of course, delta C. Since most navigation officers use a pre-calculated turning radius, r, for a given speed and rudder angle, a simpler practical formula derived from geometry is often used. Wheelover distance d is calculated as the turning radius r multiplied by the tangent of half the total change of course tangent times delta c divided by 2. For example, if you're making a 90-degree turn and your turning radius is 5 cables, the calculation is 5 times tangent, 90 divided by 2. However, the real-world calculation is more complex because it must factor in the time delay between the command to turn and the ship actually starting to respond, the lag. This lag is not just human reaction time. It includes the time it takes for the rudder to move and for the physical mass of the vessel to start responding to the rudder force. To account for this, the calculated theoretical wheelover point must be shifted ahead of the ship's current position by a small correction factor. The total distance the ship travels during this delay is known as the moment of delay advance. This distance is added to the geometrical wheelover distance. This is why navigation teams use specific predetermined wheelover data tables developed during sea trials for various speeds and rudder angles, which combine the geometrical radius with the dynamic lag distance into one practical figure. The navigator then plots this final wheelover point on the chart, measures the distance to it along the current track, and monitors the ship's position closely. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.